Hi and welcome back aboard Bridget. This is the second in the videos on installing the electrical system, and this one is going to focus on fitting the bilge pumps. Notice that I'm saying bilge pumps. Fitting bilge pumps sounds quite simple and looks quite simple in some ways, but it's not. There are a number of different types of bilge pump, and they all serve a different purpose. A decent bilge pumping system is something that gets overlooked on a lot of boats. If you're looking at a production boat, they often have completely inadequate bilge pumps. Bilge pumps come in a number of different types and sizes. There are different ways of activating them. They should be fitted in different positions, and then you have to consider the outlets. So let's consider one of the main types of bilge pump, which is this, an impeller driven pump. When people talk about bilge pumps, this is what they often think of. The way this works is it has a spinner on the bottom that sucks water and blows it out of this hole. That then goes via a hose to the outside world. Dead simple. It's actuated by 12 volts. That's an important consideration. So they work well. They shift a lot of water, but they have some major limitations. The first one is standard impeller bilge pumps are not designed for continuous operation. They're what's called an intermittent duty machine. That means that if you try and run it non-stop for 3 or 4 hours, something's going to burn out. If they're well submerged, so the water is above the pump level, then the water cools the pump. But very often they will just be working at a lower level without that cooling effect. That reduces their duty cycle quite a lot. The next thing is, what these are designed to do is shift very large amounts of water at very low pressure. What I mean by that is, if you put your thumb over that hole, you could stop the water flow completely. It's not like a garden hose where if you put your thumb over the end, you get this high pressure spray going all over the place. These things don't generate much pressure. The downside of that is that if you have the outlet a long way above the pump, then you will reduce the water flow drastically. Also, if you have a long hose and any obstructions in it, like a check valve or any sharp bends, that also creates resistance and reduces the flow from the pump. This one is rated at 2,000 gallons per hour. What that means is that if you stick it in water and just measure the output at that port, it should give you 2,000 gallons. If it's a reputable make, it probably will. However, as soon as you attach a hose to it that creates any resistance, that water flow will drop, and it will drop rapidly. I generally work on a rule of thumb that only assume that these will shift half the volume they say. So if you've got a 2,000 gallon per hour pump, expect somewhere around 1,000 gallons to be going out of the outlet. That's actually a realistic figure, especially when you start getting any debris collecting around the intake. This type of pump comes in different sizes. This one is 2,000 gallons. This beastie is 4,000 gallons. Put the two together, I can shift 6,000 gallons of water. How much bilge pumping do you need? My rule of thumb is that the bilge pumps should be capable of keeping the bilges visible if you get a major leak. So if you have something like a hose come off an inlet valve and you can't shut it off, If you have a failure on something like the impeller for the speed machine, those can produce a hole of around an inch, maybe an inch and a half diameter under water. What I want my bilge pumping system to do is to clear that water sufficiently for me to find and fix the leak. I'm not worried about whether it completely keeps it dry. I just want to be able to work on whatever is causing the leak. So how much water will come through a hole about an inch and a half diameter? One of the ways I test bilge pumps is actually to take the impeller log out. Those are designed so that you can pull the log unit out, leaving the hole. There's a blank that comes with it for closing it off. But if you just take the impeller out and let the water run in, gives your bilges a nice clean and also tests your bilge pump. They should be able to keep up with that sort of inflow. I'm not going to be recommending you fit bilge pumps that will cope with anything much bigger than that. For those of you that have a motor set up which works through a leg that is fitted through the bottom of the hull, if the gasket on that fails, no bilge pump is going to do anything. Your boat is going to sink unless you've built retaining dams to stop it. The bilge pumps will not cope with that sort of leak. Likewise, in a major collision, if you punch a 3-inch hole or tear the side of the boat open, forget it. Bilge pumps are not going to do anything. They should be able to sort out moderate and foreseeable leaks. These types of bilge pumps come in two varieties. These are manual pumps. There's also an automatic version. What do I mean by that? An automatic bilge pump is simply one that already has a float switch or some sort of device to turn it on built into the pump. They're useful in some places, and on the very small pumps they can be really useful because they enable the pump to fit into a very small space. I'm not a big fan for bigger pumps because most often if you get a pump failure, it's actually the pump switch that fails, not the bilge pump itself. I prefer to have independent float switches. These come in different ratings and different types. So this type of bilge pump switch simply has a float that is buoyant, which lifts up. Once it lifts to there, it turns on. When it drops back, it turns off. So the minimum depth of water these will go down to is about there, about the middle of the float. So that's around about an inch, inch and a half. That's fine for a biggish pump. The automatic ones, one of their advantages is they tend to work down to a lower level. So if you're fitting small pumps and you want to drain the last drops of water out, automatic pumps can be quite good. The other type of switch, more modern, is this type of thing. This is an electronic sensor. It has two contacts which detect water electronically rather than a mechanical switch. The first thing you can see is that's a very neat profile. I can fix one of these to the side of a pump to turn it on and off, and it doesn't take up much room, as opposed to fitting this, which is going to have to fasten down to the floor next to the pump, and they're quite a lot bigger. So that's the impeller type pumps. They are, as I say, good for shifting large volumes of water, but they're intermittent use. There is another type of pump, which is this beastie. It's also an impeller pump, but it has a sealed rubber impeller inside that plate, which is spun by the motor, and that has an intake port and an outlet port. First thing to notice is this actually weighs about the same as this one. And if you look at the size of the motor compared to the pump, it's quite a lot bigger. The big difference between these impeller style pumps and this style pump is also power draw. This is rated at 8 amps, so is this one. This pumps 4,000 gallons an hour. This pump shifts about 750. So in terms of water volume, that is a much bigger pump than this one. So why would you use these? The big difference is these create pressure. So in the event of too much resistance, so if you block that port, all that happens is that the impeller here just keeps spinning and doesn't shift any water. If you block the outlet on this one, the motor will keep building up pressure until it blows a fuse. This one will pump to an outlet about 4 or 5 feet above the level of the pump. That's about its maximum effective height. Even at that, you're going to have dropped your output by at least a third and maybe half. This one will continue to shift its rated output regardless of the outlet hose until it actually blows the fuse. So it will just keep upping the pressure until the water can get out. Nothing will stop it. So these are great if you've got a long run or a very deep sump. So if you've got a long way between where the pump is picking up and the outlet, these things are great. The other big advantage with these is they come with, well, they don't come with it, but you have to get it. So you also have a pickup side. So what you have is a pickup intake, somewhat like this. There's a few different sizes and shapes. That collects the water. Now notice it sits very close to the bottom of the bilge. So these will drain the last drops of water out very effectively. You then connect this in your bilges to the pump intake, which you position further up. These will suck water, and I'll show you how to make sure that works, because there is a trick to it. These will suck water up from the bilge higher up before it enters the pump. That gives you a big advantage. These are above the high water mark. They stay dry all the time. That makes them extremely reliable. They also have whacking great motors. They're made of bronze. They're extremely robust, and they're rated for continuous use. This will keep pumping until your batteries go flat. The downside, of course, is this costs more than this. These things are, for the amount they shift, they're super expensive. Depends where you get them from, but you can pay $300 or more for one of these, which, given that it's only pumping about 750 gallons, that's a lot of money. But in the right place, they are a godsend. Okay, right, the last item on the list of absolute essentials for any decent bilge system is one of these. It's a buzzer. You could also use a light as well. You need to know if there's water coming into the boat. Don't rely on hearing the bilge pump. Yeah, your bilge pumps might make a noise. You might hear them when they turn on. You won't hear them when they fail to turn on when water comes in. What you need is a bilge alarm connected to a float switch, so that if you get water building up in the bilges, then the alarm will go off and it will warn you that you've got water coming in. Okay. So, last point, when we're talking about water coming into a boat, we're looking at two things. Normal ingress of water. Boats live in wet environments. It rains, there's waves, there's spray, you get wet. You walk down into the cabin, take off your oilskins which are dripping and hang them up somewhere, that's running into the bilges. You get a bit of spray or rain through a hatch, that finds its way into the bilges. Somebody spills water out of the kettle. There's 101 different ways you'll get water in the bilges. That is perfectly normal. The pumps we use for that are called dewatering pumps. I'll show you one later because it's already fitted. They're small pumps fitted very low in the bilges in a way which is designed to collect the last drops of water. That's the pump that keeps the bilge dry under normal conditions. It's really important to have one of those because your main bilge pumps, these things, you don't want these to come on unless you have an emergency. These should be fitted so that normally they're nice and dry and out of the water, and that makes them reliable. If you rely on a main bilge pump to do everything, so it's constantly getting wet, it's constantly working, when you have an emergency it's more likely to fail. It's also not going to keep the bilges dry, it's only going to keep them down to a few inches. So you'll always have some water slopping around in the boat, which you don't really want. So there are two functions of bilge pumps. Dewatering takes the last drops out, keeps the bilges dry and copes with the normal spray, drips and spills that you inevitably get when sailing. Bilge pumps are for emergencies, for if something goes wrong and the boat has a leak, and they should ideally be kept to just do that job. The final thing I would say is bilge pumps always come in pairs. Not necessarily matched in sizes, but these are my two main bilge pumps that I'm going to be fitting. So if one fails, the other one still works. Always have a backup fitted. These things are not the most reliable device, and as I say, they have a finite life. I have on one occasion had a major leak in a boat. I had a collision which ripped out some stanchions, leaving holes in the deck. It was gale conditions, there was a lot of water coming in. I had one of these pumps fitted, it coped perfectly, kept the bilges nice and dry. It lasted about, I think, 5, maybe 6 hours, and then it burnt out. So I spent the next 18 hours using the hand pump. You want a hand pump as a backup. Your bilge pump, your electric bilge pumps are only as good as your batteries. The first job when installing your bilge pumps is to work out where things want to go. Fitting your bilge pumps. So the first thing you have to do is to work out how many pumps you need, where they need to go, and how they're going to physically fit. Now if you look at my sump, this is the main bilge. Although this is a traditional hourglass hull, it's got internal ballast. That means that the keel is basically filled full of lead with a concrete top. That makes quite a flat bilge. A lot of boats have a fairly shallow flat bilge, and that matters when you're sorting pumps out. So my recommendation is always that the main sump should have 3 pumps, each of which does a different job. So the first one is this little one. This is an 1100 gallon per hour automatic pump, but notice it's in a small well. If at all possible, you want a small sump that fits this pump into, where the last drop of water is going to drain down. That's the way to have a dry bilge. If this was completely flush with no well, then you would finish up with quite a lot of water collecting on this flat bottom. If the boat heels at all, it's going to fill up one side. That means you're going to need to take quite a lot of water into the bilge before the pump can activate. If it's in a small well like this, then that's going to keep, because no pump will pump completely dry. They all leave an inch or so, somewhere between 1 and 2 inches of water that they can't collect because the pump turns off. Yeah. Okay, this is a good use for the automatic style pumps. They'll fit into very small spaces. The actual volume on this pump doesn't really matter. Somewhere between 500 and 1500, anything like that will do. This is to collect the last few drops of water. If you get a bit of spray through a hatch that drips off your oilskins, all of those normal means that a bit of water gets in, we want to deal with those without stressing our main pumps. Okay, now we get onto the actual bilge pumps. And the reason I'm saying 3 bilge pumps is because you always want a fitted spare. So the next pump is this one. This is a 2,000 gallon pump, and this small black box is an electronic float switch. They're pretty good. They will trigger very reliably. They're solid state, so no, you can't get any debris blocking a float switch. Then they're quite a good option for this. This is the first stage in bilge pumping. So if I have more than those few drips and a bit of spray, if I actually have you're in a bit of rough weather and you get a slop of water down a hatch, you get a minor leak, something like that, the bilge starts to fill up. This is where you need to get on to higher capacity. So 2,000 gallons an hour. If the bilge was up to the floorboards, it would probably clear that in 15-20 minutes. Hopefully quite a bit less. But for normal foreseeable water ingress, 2,000 gallons per hour will do. There is a bit of a myth that small boats can use smaller pumps. That's actually not true. Small boats still need big pumps. The reason for that is the object of the bilge pump is that if you have a leak, a failed fitting, a hose comes off, whatever, something is letting significant amounts of water into the bilge, what you need to do is to find and fix that leak. And you probably are going to need to do that with some urgency. So the idea of the bilge pump is it keeps the water level down low enough for you to find the problem. On a small boat, the sump fills up very quickly. So you get, for example, a hose comes off one of your skin fittings, leaving an inch to an inch and a half hole. That will let in a lot of water. It will fill the bilge up to the floorboards in a few minutes. No, that wouldn't give you time to find where the problem is. Once that fitting is underwater, it becomes much more difficult to find and fix. So what I want the bilge pump to do is to keep the water down so that I can find any problems and where the leak is coming from, rather than dry the bilge. I particularly don't want to use my main bilge pumps for the slops and drips and normal things that happen on a boat that get water into the bilges. These are emergency pumps. They're for when something goes wrong. I don't want them to work any other time. This little one is the one that's coping with normal water. If it fails, okay, as long as I know it's failed, I can swap it out. No great problem. If that pump fails, it doesn't affect the safety of the boat. It just means that I'm running around with a few inches of water in my bilges. If this one fails, that's serious. It means it's not going to do its job if I have an emergency situation. So if I have this one constantly running, trying to get the last few drops and the normal amount of water that comes in, if that's running regularly, that's all wear and tear on the pump, wear and tear on the float switch. It's going to make it less likely to work in the emergency when I actually need to rely on it working. So I want this one to stay above water level and dry as much as possible. Okay, next thing is, these are not continuous duty pumps. Although these impeller pumps are extremely effective, they'll shift a ton of water, and they're pretty reliable for the use they're intended for. They are not designed to run for 3-4 hours. Particularly if they're running with the water level around here, then after some time, most of them will overheat and the motor will burn out. If the pump's actually completely submerged, weirdly, that's better because you've now got water cooling the motor. That will extend their life. But they are only rated to work for about 20 minutes in an hour, and then they need to switch off and cool down. So they're not continuous duty pumps. Also, they live in the bilges. It's usually a bit damp. It's not brilliant. Wiring is vulnerable. There are lots of reasons why bilge pumps fail, and they do that on a fairly regular basis. So relying on a single pump to save the boat if you spring a leak is asking for trouble. That's why I say minimum 3. You want your dewatering pump to clear the last drop, and then you want 2 bilge pumps. Particularly if you've got a flat bottom boat, that's even more important. If I just had this one pump and I got a leak and I'm on and I'm heeled to starboard, then the water level is going to fill up. If I'm heeled at 30 degrees, the water's going to be nearly up to the floorboards on the starboard side before the pump even activates. If you've got a fairly flat sump, then ideally what you want is 1 pump each side. That will shift water much more effectively than a single pump in the middle. The other one is volume. If you lose, so that 1.5-inch hose comes off, you've now got an 1.5-inch hole in the boat. Even if it's only 6 inches to a foot below the waterline, that is going to let in way more than 2,000 gallons per hour. This pump will not be enough to cope. This one on this side is my main pump. So this is actually 4,000 gallons. That's more like it. I would say 4,000 gallons is about a minimum size you want on any boat. You could maybe do that by having 2 2,000 gallon pumps, 1 on each side. I had a 4,000 gallon, so yeah, obviously I'm going to fit it. You could actually quite happily put a 4,000 gallon pump on each side. That would be a really good solution. I will guarantee that will keep your boat fixable in the event of any leak where you're going to save the boat. If you punch a 2-foot hole in the hull, then you're going to sink whatever. So add these together, I've got 6,000 gallons per hour. That's an effective pumping capacity. As I say, minimum 4,000, 6,000 to 8,000 is better, and make sure your pumps are backed up. Now the next thing about this is this one sits right on the floor. So once I get water, that's going to trigger and start working. This one, you can just see down here, is mounted on wooden plinth, so it's raised an inch off the floor. So these work in steps. This one copes with a small amount of water draining into there. This one kicks in if you get some water in the bilges. If the water coming in is more than this pump will cope with, then it will continue to fill up, and then this one will kick in a little bit later. Okay, so that gives you staged pumping. The important thing is this main bilge pump, my 4,000 gallon one, is only ever going to come on when I've got a major leak. So this is the emergency backup for when you really need a bilge pump. Don't forget, incidentally, you're also supposed to have a hand pump. I have had a situation where we had a collision. The result was that some of the stanchions on one side got ripped out, leaving holes in the deck. We were in rough weather, so we were getting a ton of water coming in. I had one of these 4,000 gallon pumps fitted. It worked fine for about 6 hours, then it burnt out. There's also the point that your electric bilge pumps are only as good as the batteries they're attached to. So when your battery goes flat, the pump stops working. That's when your hand pump comes in. I had a big hand pump on that occasion when we had the collision, and I could lie in my bunk pumping away, and I did that for quite a long time, and that's what kept the boat dry. So don't forget your hand backup as well. Okay, next thing about positioning pumps. This is my main sump. I also have two other areas where water can collect. I've got a small sump forward, which has got a different pump fitted to it. I've also got a small well just underneath the prop shaft fitting. Where, so yeah, traditional prop shaft fitting does drip a bit. Directly underneath that is a small sump which will collect those drips and stop that water running down into the main sump. So you may want to look round on your boat and say, right, are there any other areas where water might collect where I need additional pumps? Okay. The final thing I want to look at in this section is how to make reliable connections in the bilges. As I keep saying, the bilges are a horrible place for anything electronic. So, how do we make a connection that will work in this environment? If I'm extending, bilge switches and bilge pumps never come with long enough wires. They won't reach. Ideally, they would give you enough wire to be able to wire it into your pump panel, but they never do. If you need to extend the wires, it's permanent. You don't need something that you can take apart. If you ever need to change it, you just cut the wire and make a new connection. So we're looking at making a permanent connection. Okay, and what I prefer to, you could use just a pair of standard crimp connectors. You could use an inline connector. What I prefer to use is these things. You probably can't see that, so I'll describe it. Basically, it's a length of adhesive lined heat shrink tubing which has a ring of low temperature solder in it. When I use a heat gun to shrink the heat shrink onto the wire, it will also melt that solder, creating a permanent connection. What I also want to do, this is adhesive lined heat shrink, it forms a seal, but because it's in the bilges, I also add a length of heat shrink over that, so that I've got double protection. That's one of the reasons for using an inline connector. These are much slimmer than a spade terminal, so I can use a heat shrink over it that will definitely give me a good seal. It's quite difficult to get a heat shrink which will go over a spade connector and shrink down enough to really seal around the wire as well. These are easy enough to use. All you do is slide the wire in until it's within the solder ring. Get your other wire and slide that in. Right, and then with the heat gun, takes a bit more heat than just using ordinary heat shrink, and then just hold it for a few minutes until it cools. Once you've got your connection made and it's cooled, slide an extra length of heat shrink over it and just blast that until it shrinks in place. Right, and that makes a good waterproof connection. The last thing we need to do below the floorboards is to install a high water bilge alarm. You can see the one I have here. So this is the high water alarm. I'm using an electronic sensor. You could use a float switch as well. You can do this by teeing into the power feed to the pump. So that is between the float switch and the pump. That will certainly work. I don't like it for two reasons. One is it means breaking into that wire which is going to be in the bilges. And I want to minimise any connections that could potentially get wet. Bilges are a horrible environment for electronics. They're always damp. The other thing is that it means that your high water alarm is going to go off whenever that pump operates. Now, if you've got this staggered pump set up, teeing it into your big bilge pump, which is the last one to come on, would probably work. On the other hand, when that pump operates, I'm going to hear it anyway. It's pretty noisy. What I prefer to do is to use a separate pump float switch, because that way I can set it higher than the float switch for the biggest pump. What that means is that if the pumps fail and don't come on, then I'm going to get a bilge alarm. If the pumps do come on but can't cope with the amount of water coming in, the water level is going to keep rising until it hits this switch, and then it's going to sound the alarm. That tells me that either my pumps haven't worked and water is rising, or my pumps have worked but they're not shifting enough water and the water is still rising, which I think is more useful. Quick tip. You know, there are times when you're trying to drill a hole and you haven't got exactly the right size hole saw. This is about 1/8 of an inch or less bigger than the hole is cutting. If you take a strip of self-adhesive sandpaper, peel the back off. Try and peel the back off anyway. Right. And then simply wrap it round a hole saw. Right, can now use that to sand the hole out to the size that I need. I said in the last video that I was going to show you how I do labels for wires. What I use is a Dynamo 4300. This shows the installation of the forward bilge pump. You can see the pickup with an electronic sensor in the sump. Not that easy to see. This is the pump itself. Notice that the intake pipe coming up from the sump, from the bilge, goes up in a loop and then down to the pump. There's a good reason for this. These pumps don't like to run dry. If they run dry for more than a few seconds, it will damage the impeller. So by putting that loop in, it means that even if the pickup drains, which theoretically it shouldn't because it's got a check valve on, then that will still retain water in the impeller, so that when it starts up, it's already primed. This hose is highly flexible corrugated hose. In some ways that's not ideal. It's very easy to fit, but because it's corrugated, that causes turbulence in the flow, so you actually have more resistance in the hose than you would have in a smooth hose. For these smaller pumps, I'm not super bothered about that. It's not critical, the amount of volume these pump. And in any case, an impeller pump will overcome pretty much any resistance. The reason I'm using an impeller pump for the forward bilge is because it's a very long run to the outlet. These pumps will overcome pretty much any pressure head. They just draw more current if they have a higher pressure head. Consequently, although this is only rated at 600 gallons per hour, it will almost certainly pump far more than something like an 1100 gallon impeller pump, because it will still be pumping its rated amount overboard regardless of the height or the resistance in the line. Okay, so we've got the pumps installed below the floor, we've got everything wired up, we've checked everything, the pumps are now working. Floorboards are back on. Next job is to look at how we get the water from the pump to outside the boat. That's the whole point of a bilge pump after all. Every boat is different, the layout is different, the furniture is different, the route those pipes take is going to depend totally on your boat, and you're going to have to solve that for your particular boat. There are some principles which I'm going to go through, which are really important to make sure your bilge pumps work properly. The first thing is height. So you have to have the outlet for all the pumps above the heeled waterline. That means however much you tip the boat over, I would say practically to the point where there's water on the side decks. It's coming over the side of the gunnel. At that angle of heel on both tacks, your bilge pump exits need to be above water. This is really important, and not for the possibly most obvious reason. If your outlet goes below the water and the pump turns on, you've now got a full pipe which is leading out to underwater. If that pump stops, you now have a siphon, so you're going to suck seawater back in through the pipe because the pump is a lot lower than the water, and you get a siphon effect. So your bilge pumps will then start to fill up the boat. Okay, as soon as they fill it up enough, the pump's going to kick in, but you're going to have a cycling pump, which is really bad news and flattens your batteries pretty quickly. So every outlet must be above the heeled water line. That tends to mean you can't have outlets at the side of the boat. Would be really nice if we could put pump outlets midships, because that's usually where the pump is, and that then makes the shortest run to outside. But you can't do that because the pipe is going to be below waterline when the boat heels. The second thing we want to look at is the pump wants the shortest, straightest route it can have to make the pump more efficient. It's always going to be a compromise. You've got to have some pipe, it's got to lead to the outside world, and that's usually going to mean 10 or 15 feet of piping. Generally speaking, where most people will put their outlet is going to be on the transom. Nice flat bit, usually above water, doesn't dip when you heel. That's the logical place to put it. You may find that more difficult than you think. How are you going to get the pipe from where the pump is to there? If you've got a lazarette, that might solve a lot of problems. Quite often the transom is not as accessible as it might be. So you're going to have to look at your boat and say, I want a site which is always above water, which I can get at both sides of, because you need to attach the pipe and do up the clamps. You need to be able to drill the hole. That's basically it. Your outlets don't need to be at the level of the guddle. In fact, that's often not the best place to put them. What we do want though is that at some point, ideally as near the pump as possible, the pipe will loop up to deck level. The ideal solution would be you go straight from your pump, you go up the side of the boat, you loop round just underneath the deck, and then you run your pipe aft. The reason that's ideal is because if you can get a continuous slope from that high point to the outlet, the pipe's going to drain. That would be great. You've got minimal water left in the pipe when the pump turns off. That water's going to run back. You're going to have less problems with pump cycling. There aren't many boats where you can do that. Okay, so very often what we're going to do is run the pipe aft to the transom and then take it up to deck level, make a loop, take it back down, and then out somewhere convenient to attach the clamps, which is above the waterline. Don't worry about that creating extra head, it doesn't. If your pipe goes up to the deck and then down, the distance that matters is from the height from the pump to the outlet. The fact that it loops up doesn't increase your resistance. Simple reason that any water which is in that pipe, gravity is trying to pull it out, so it's actually going to pull more water out. So the height you're pumping is from the pump to the outlet, not to the highest point on the hose. Okay, so I'll show you how I've arranged mine by going outside. Okay, so this is where my pump outlets come. You can see I'm about halfway between the waterline and the gunnel. The other thing to notice is this is a canoe stern, so there is no transom. So I'm at the side of the hull. That's fine. On the inside, the pipes loop up until they touch the deck head and then come back down. So even if I did get a bit of a wave that just slopped over the end of those hoses, it's still not going to come into the boat. When we're talking about looping hoses, what we need is to make the loop so that water can't come back in. So normally we do that by taking the pipe up to the deck head and then back down again. But if you think about it, imagine the boat heels over. So we're now heeled. You could actually create a loop which went from the outlet sidewards to the other side of the boat. It wants some rise on it, but that would effectively make an a loop that would stop any water coming back in. So it doesn't necessarily need to be straight up and down. It can be at an angle, as long as it is somewhere where, imagine where the pipe is. So imagine that a pipe loops sidewards across the boat. That top of that loop is always going to be well above the heeled water line. If you go the other way, the outlets are way above the water line, so there's no chance of water coming in anyway. The final detail is to sort out the routing for the pipes and fasten everything in place. Remember, once the pipes fill with water, they're going to weigh quite a bit, so they need to be strongly fixed. Zip ties are fine, and then screwing things to the hull or strapping them down firmly some other way.